Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4. For this video, we would like to present about flood mitigation at Taman Universiti Parit. As you can see, this is members of Group 4. Let me introduce myself. My name is Atira and the others is Hari Urshidi, Juninho, Longinesh and Maizura.
Okay, for now, I would like to present about the introduction. First of all, I would like to introduce my name. My name is Maizura binti Nushamuddin and my metric number is CF220239. Okay, for the introduction, the study area for this project has been stated in the project instruction, which is at Taman Universiti Parit Raja Batu Pahat. The existing drainage existed by the main road approximately 491 meter long and has a depth of 2.5 meter and 4.5 meter wide, while the average slope along the drain is meter. An open channel or drain system micro drainage is often made up of a secondary drainage system with a network of small drain attached. Each serves a small catchment area consisting of a single house or a number of apartment buildings. WHO 1991. This little drain carry water to the main drainage system, which include main drain, also known as interceptor drain, that serve a large area of the city. Okay, next for the objective project. The first one is suggested an appropriate drainage system capable of efficiently reducing the heavy flow. The second one is determine the appropriate type and size of drainage system for Taman Universiti Parit Raja. And the last one is examine how water flow through the proposed drainage system at Taman Universiti Parit Raja.
Hello, my name is Juninho. So today I'm going to talk about methodology. So the aim for this task was to complete the drainage plan in the Parit Raja section of Taman University to correctly suggest a drainage design that works. The area's climate and condition were designed using an appropriate analysis process. According to information from the past few months, the region was vulnerable to flooding because of flash floods, which happened after heavy rains. Firstly, the area was a survey by our team members to study and collect all the information that can be obtained in the area. The area of catchment was also calculated by using Google Earth on the website to get the area and dimension of the desired area. The total area of water washed is 107,959 millimeters square, which is 26.677 acres or 10.796 hectares. The rational method was used to properly calculate the data analysis. The Urban Stormwater Management Manual for Malaysia was used to identify peak discharge Q for the area. The first method of this calculation method is the Manning roughness. To start the calculation, we need to get data from the table. During our site survey, our team concluded that the area of grass drain with short grass cover is lower than 150 mm. The Manning roughness N is 0.035. And then the dimension and area of drainage. The drainage design from our group members' information was trapezoidal drainage, which is located in front of Suhaila Bistro, has an area of 25.31 mm square. Z is 2.25 and the perimeter P of the drainage was 9.5 meter. From all the information taken from trapezoidal drainage, the hydraulic radius R of the drainage was calculated and the result was 1.5068 meter. Next is friction slope. Using the friction slope equation, the friction was calculated and as a result, the value of friction slope was 0.004 meter. The equation was using the highest value elevations, which was 10 and the lowest value elevation was 8. The length of the channel is also required to calculate using the equation. Next was empirical IDF curve. Table 2.4 here was used to identify the IDF curve of the area. The needed data was collected in the area in Johor and the station near sector JPS Batu Pahat. Through the data, we can get the constant value of the area, which is 64.099, K is 0.14, and the theta is 0.201, and N is 0.826. As we all know, the area of this case study was commercial and business type, with a minimum ARI per year was 100 years. The information was from table 2.5 below. After information about the area was taken, the equation below was used to get empirical IDF curves. The empirical IDF curves I was 435.98 mm per hour. To calculate the runoff coefficient and peak flow, we need to refer to table 2.6. We need to choose the type of land use of the area. The area's land use was commercial and business center with a runoff coefficient below 10 years was 0.95. Peak flow can be calculated using all the information. The peak flow was calculated by using equation 2.3. The peak flow of Q was 25.89 meter cube per second. Lastly, we need to find the Q assumption for the new design of drainage. The Manning equation was used to calculate the Q assumption. Area, weighted perimeter, and the slope were calculated before we use the Manning equation. Then we proceed to calculate the Q assumption. The peak flow of the proposed design is much bigger, which is 31.47 meter cube per second than the existing drainage. Peak flow 35.89 meter cube per second. So the proposed new design is considered pass based on these calculations.
My name is Noatira binti Parit. So Longinage and I will present result analysis part. So the survey study was conducted in designated area with information that helped to complete our project. So we measured the width and depth of the drainage by using measuring tape, and then the special work made to the study about the direction of drainage flow and determine the causes of flash flood at Taman Universiti Parit Raja. So I will present drainage from BHP to McDonald. So as you can see, here is a drainage for all design. So the shape is like trapezium. T is 5.3 meter, Y is 2.5 meter, and B is 4.5 meter. Okay, for the first time we have to find area, weighted perimeter, and radius. So our area is 22.5 meters square, P is 14.8 meter, and R is 1.52 meter. And then we have to find friction slope, which is S. So our S is 0.004 meter. And then we have to determine the Manning roughness, which is our drainage is short grass cover less than 150 millimeter. So our N is 0.035. And then we move to time of concentration. We have to calculate TD, which is travel time in drain flow. So our TD is 3.48 minutes. So we have to change minute to hour. So D is 0.058 hour. So based on the state Johor, station ID 1829002 and station Institut Daerah JPS Batu Pahat, so we can find our fitting constant dependent on the rain gauge location on the MASMA edition book. So next we can get the T equal to 100 based on the ARI year in commercial and business. After get all the information, so we can calculate average rainfall intensity, which is I. So our I is 435.98 millimeter per hour. Next, we can calculate for runoff coefficient and peak flow. So our runoff coefficient C is 0.95 based on the commercial and business. So last step is we have to find peak flow. So our Q is 14.97 meter cubic per second. So as you can see, this is new design for drainage PHP to McDonald. So we increase length for T and Y. For the T, 6.5 meter, Y 3 meter, and for the B is 4.5 meter. So we have to find new area, new weighted perimeter, and new radius. So our new value is A equal to 27 meter square, P is 15.8 meter, and R is 1.71 meter. For the friction slope is this same with the old design, which is S equal to 0.004 meter. And for many roughness, we have to refer the table. So our N is 0.035 meter. For time of concentration, we have to find travel time in drain flow, which is TD. So our TD is 3.22 minutes. So we have to change to hour. So we get D equal to 0.054 hour. Next, based on the station name and station ID, so we can refer MASMA book. So we can get all the fitting constant dependent on the rain gauge location. And for the T equal to 100 because of ARI year in commercial and business. So we have to replace all the fitting constant into the average rainfall intensity formula. So we got I is 441.62 millimeter per hour. Next, we have to calculate runoff coefficient and peak flow. So our runoff coefficient we get from table 2.6 based on the commercial and business. And for the peak flow, Q peak is 15.15 meter cubic per second. Since Q that we designed 15.15 meter cubic per second is more than Q peak, so the new design that we provide is pass.
For the design of the old drain, which is from the Suha restaurant to the coffee shop, is 1.6 meter wide and 1.4 meter long. The area for this drain is 2.2 square meters and the radius is 0.50 meter. The ID that used for this station is 1829002 and the station name is JPS Batu Pahat. The run coefficient value is 0.95 and the flow area for this area is 4.96 hectares. And the peak flow for this drain after the calculation is 6.43 cubic meters per second. This is our new purpose design, which is 3.0 meter wide and 3.0 meter long. The area for this drain is 9.0 square meters and the radius is 1 meter. The same ID is used for this station. For the value for the run coefficient is 0.95 and the flow area for this is 4.96 hectares, remaining the same. And the peak flow after calculation for this drain is 6.67 cubic meters per second, which is new design peak flow is higher than old design peak flow.
Hello, my name is Harith Rushaidi bin Abdul Rahman, metric number CF220013. For discussion, as we did the calculation, we found that the both of the flow designs of the drainage were found to be higher than flow peak of the discharge, which means that the proposed new design of both channel section is passed. Not only that, we found that the flow rate of each drainage size is different in terms of length of the channel and its depth as shown in the table. These are the table of comparison, old and new drainage. As you can see, both of the drainage has increased in size. As a conclusion, hydrological research is crucial for the success of many civil engineering projects. Hydraulics is a wide-ranging discipline that is essential to society, particularly in civil engineering where it is used to build infrastructure for water supply so that any adverse environmental effects are minimal. One of the fundamental responsibilities of the design and engineering team is to make sure that there are no drainage problems on the job site, particularly in terms of the effect of structural work in the event of an inconsistent or unfavorable condition, like a rainstorm that results in flooding because of out-of-date drainage.
That's all from our presentation. Thank you.